Our next way of solving our system of three equation is by using our Gaussian elimination process. If you look over here, it does give you a description of how the process works, but I'm going to work it over here for you. So maybe once you might just kind of skim over that and then watch the video and then go back and kind of bring the two together. So since we see the word elimination, this is basically how we are going to approach this problem. So I'm going to take my first equation, I will make that one blue, and I'm going to take my second equation and I'm going to make that one purple. And what I'm going to do is I'm going to add them together. Oops, minus C. And our second one, negative 2x plus y plus 2z equals 6. All right, I'm going to add them together. And why do you think I'm choosing these two to add together? Are you noticing that I'm looking at the fact that my coefficients are a positive 2 and a negative 2, so when I add them together, what's going to happen? Negative 2x plus 2x, they are going to cancel out. So then I'm going to add my y's. 1y plus 1y is 2y. And negative z plus 2z would be, or give us 1z. And our 4 plus our 6 gives us a 10. And now we're going to repeat the process. So I'm going to take my first equation again. Notice I have rewritten it here. And I'm going to take my third equation. We'll make that one the green one. And we're going to do the same thing. We're going to eliminate the y. So our second equation is x plus 2y plus z equals 11. Now, this one's a little different because my coefficients are a 2 and a 1. So I'm going to have to do some manipulating here. If I add a negative 2, if I multiply by a negative 2 to my second equation, that will then give me the coefficient that I need to cancel. So distribute your negative 2 to everything here. I'm going to put it over here, so we'll distribute there. So your negative 2 times 1 would be negative 2x. Negative 2 times the 2y would be negative 4y. And negative 2 times z would be negative 2. Z equal to 11 times negative 2 for a negative 22. So now I've just taken my first equation and brought it down. So now here is my system here now that I'm going to add. Now you can see that when I add the negative 2x to the 2x, they cancel out. Now I have a negative 4y plus y for negative 3y, and negative 2z minus z for negative 3z, and then a negative 22 plus 4, negative 18. Okay. So now here's what I want you to look at. I want you to look at the two red equations that we have left. You notice that they both contain a y and a z. So from this, now we have a system of two equations. And then from here, you will just proceed to solve it like you would a system of two equations. So I'm going to go to the next slide so I can write all this down. And in the meantime, you pull these together and I'll show you. Okay, so I have rewrote this on the next screen. We'll just ignore this. Okay. So now I need to decide, do I want to eliminate my y or do I want to eliminate my z? Well, if I'm looking at this, I do see that I have a positive 1z in my first one and a negative 3z in the second one. So I'm going to eliminate my z, so I'm going to multiply my top one by a positive 3. So we'll work this way. That gives, now let's work down. So that would give us a 6y plus 3z equals 10. Carry down your second one unchanged. And now add them up. So we get 3y, my z's are gone, equal to all right, I'm going to go back up because what I forget to do, I have to multiply it with all of them. So I forgot this one over here. 3 times my 10 for a 30. Now I'm going to add the 30 and the negative 18 together. And I think that would give me a positive 12, or that gives me a y equal to 4. Okay. Now, just like we did with the substitution, now we're going to stop and start working ourselves backwards. Now I'm going to take this y value and I'm going to sub it back. I think I'm going to take it back to my original one here. So that gives me 2y, so I'm going to replace it with my 4 that I just found, plus my z equal to 10. So that would give me 8 plus z equal to 10. And solving that for z, when I subtract the 8, I would get z equal to a positive 2. Okay. Now we're going to take these two values and we're going to go back to our original, one of our original equations. I'm just going to go back to equation 1. So I had, from my first equation, I had 2x plus y minus z equals 4. So sub in your y value that you found and your z value that you found. So we would have 2x plus our y value that we found to be 4 minus our z value, our z is 2, equal to 4. Clean it up. 4 minus 2 is 2. Move your 2 to the other side. 2x equals 2. And therefore our x would equal a 1. And there is your x value. So let's write it as a finished ordered pair. X was 1, z was 2. Well, we don't want that, we want y. Y is 4, and z is 2, and this is your ordered triple. All right, so these are harder than our systems of 2 equations, so it will take a little more practice. Do not get discouraged. I will help you when we're in class, and I will see you then.